Hey, hey. Before I even get started, we just had our third birthday as a company. How many of you know Slack? Nice. This is fantastic. This is pretty cool. We've been doing this for 3 years now, so the more hands I see every single time I go and talk anywhere, the better. It's good news. So we're going to talk about desktop applications with JavaScript today. And before I get started, let me quickly reiterate what we want to do at Slack. Our very mission is to make people's working lives simpler, more pleasant, and more productive. And to an extent, that also includes the people working at Slack, the people building Slack, the ones that actually try to achieve this mission at its core. If you've never seen Slack, at least the desktop application, this is what it looks like. My name is Felix Wieseberg. I'm one of the 4 people building this application. And we're the ones building it for all platforms. When I say building it for all platforms, I want to briefly talk about what that means. When we talk about desktop software, we usually target 3 main operating systems, right? We target Windows, macOS, and Linux. And in theory, that just means you build 3 applications. Just 3, that's already 3 teams, pretty big. But in practice, it really means something else. In practice, it really means that you have Windows 10, and you might do something like a native Windows 10 app. But then you also have the Windows Store, which is available on Windows 8 up to Windows 10. But then you might be selling to customers who are still running Windows 7. By the way, is anyone still running Windows 7 here in the crowd? There's a few hands. Please update soon. It's terrible. You don't know what you're doing to yourself. It's bad. But anyway, so just like this, I cut your Windows team, again, in 3 parts, right? We have 3 different versions of the application just for Windows. On macOS, it's slightly less terrible. We usually just have macOS. Apple is pretty brutal in what they support and what they don't support. Apple has just dropped support for 10.10, which for the Windows crowd came out way after Windows 7. But on macOS 2, you also have the App Store, which works in a slightly different way. You can't just take your macOS application, put it in the store. It's like slightly different. So again, you have more targets. And then Linux is its own terribleness, right? We have Debian and Ubuntu and their various versions, and then we have Fedora and Red Hat and their various versions. So when you're building software, when you're building desktop software, this is really what you got to target. And it's honestly pretty terrible. So again, my team is 4 people, meaning that if we were to build applications for each of those platforms, you know, we can like spend a day on the Windows app and then another day on the Mac app, and just like that, we are probably going to achieve applications that are not great. Right? The core idea of building desktop software is that it's something that makes people's lives more pleasant and more attractive, and they enjoy working with Slack. So what we do instead is we build desktop software in JavaScript. And usually when I go out and talk about building desktop software in JavaScript, people aren't super excited on both ends. This includes people that usually build native software, as well as people usually write in JavaScript. People have reservations, which I can understand. The fact of the matter, though, is that if you use software at all, anything, if you use something like Visual Studio Code, actually, I'm going to do this as a little exercise, all right? I'm going to go through some apps. Just raise your hand if you have them on your computer. Spotify, Atom, Visual Studio Code, Slack, Postman. The fact is that there's so much software out there today that is mainly written in JavaScript for this specific purpose, to ensure that you can only write one application, and that one application can be shared on all platforms, meaning that you just have to write one excellent application that then delights users on all platforms. And we use something called Electron for that. It's a very popular framework these days. Slack is actually part of the maintainers group of Electron. I'm one of the maintainers of Electron, and we actively help GitHub, who's running the framework, to build this excellent framework. And I'm going to talk a little bit about what Electron actually is. So on the very left, you see the logo of Electron itself. And let's briefly take it apart. What is Electron? It's an equal parts Node.js, a very powerful solution to build software in JavaScript. Node.js itself is cross-platform, runs on macOS, Linux, and Windows. So we already get that part of the area covered. And then we have Chrome. You might know it under a different logo. That's the logo of Chromium, which is the open source core of the product Chrome that you might have on your computer. Chrome, as in software by Google, is basically Chromium combined with a bunch of value-added benefits that Google bolts on top of Chromium, the actual software. And then we have C++, and that's the important part. Whenever we talk about desktop apps in JavaScript, people usually say something like, oh, this has to be slow, this has to consume more resources than it actually needs. But the idea is that you build the easy parts, which usually is only 90% of your application. You build the easy parts in JavaScript and HTML, and then you do the hard part in C++. For many applications, there's no hard part whatsoever, right? This is true for many, many apps. Spotify, for instance, I have not seen the Spotify source code, but I would be hard-pressed to think about what they would actually need to do natively. They can probably just do everything in JavaScript. Whereas in the case of Slack, we, for instance, have video calls. Video calling is something that you might want to do natively, so we do that natively, but everything else can still be shared across all platforms. Okay, this is going to go into some actual code real quick, but before I do that, I want to talk very briefly about what that means, right, just for a second. This is not my last slide, but I think I got like one more. When you start Electron, we spin up something called the main process. It's just invisible. There's nothing happening. And if you have ever done anything in Node.js, you're now in a Node.js process. Works exactly the same way. The one difference here is that this Node.js process, the JavaScript that you write, has the power to open up windows, right? New windows, browser windows, which we do quite liberally at Slack. When you start Slack, we first start this invisible process, and then that process does a little bit of housekeeping, makes sure that you have the latest version, makes sure that we are on the right platform, and so on and so forth, and eventually starts running Slack by opening up a window and loading Slack. And again, in this browser window, we have Node.js available, which is pretty cool. So whatever you like about Node.js, you now have that available in your Chrome window. And then, of course, those two processes can talk to each other, which is something that in a website you can't really do. If you ever built a website and you want to talk to another website, you can't really do that directly. You also can't really talk to the computer directly, right? You can't just save a file from your website. That's not all that easy. You can't just access the disk. And in addition to that, you can open up multiple processes. You can have as many windows as you want. So that's a very quick primer. And if you look at something like Slack, our architecture is pretty straightforward. We have a pretty decent core of C++, which is everything that we need to do in C++, mostly native APIs. And then we use React, TypeScript, and of course Electron. It's otherwise a pretty typical web application, except that we get to run on the desktop. And this would be the native component in C++. All right, that's that. What I'm going to do now is I'm going to quickly build something called Visual Studio Code. I don't know if any of you have ever seen Visual Studio Code. It's this editor. It's a powerful IDE made by Microsoft. It's free, it's open source, it's quite fantastic. And it's also written on Electron, which makes the whole thing sort of interesting. When we talk about Electron and we talk about Visual Studio Code, the core idea is usually that you have built something like a web application and you want to take that application to the next level. And this is true for Visual Studio Code too. So if I look at something like Visual Studio Code, there used to be a thing called the Monaco editor, which is a project made by Microsoft. I don't know how fast the internet here is, but it works pretty well. So if you have ever used Visual Studio Code, you might be familiar with this thing. And Visual Studio Code really is that a team made this editor here, which works exactly like Visual Studio Code. It has all the same things you might be familiar with. And somebody in the team was like, what if we packaged the whole thing up? Maybe we would have a pretty decent editor. And that's pretty much what happened. And just as an example, we're going to do the same thing. We're going to build a little code editor. So jumping back to Visual Studio Code. Just to familiarize yourself with this real quick, what I have open right here is the package.json, which is maybe familiar to you if you've ever done anything in Node.js. Whenever you do anything in Node.js or install anything with NPM, you have a package.json. I don't really have anything in here. The only thing of interest really is this Electron part right here. I installed Electron as a dependency, and I can start Electron with this command. Right? Normally it is this. That's what you would do if it's Node. In this case, it's just electron dot. And that then goes ahead and automatically runs my main file, which is currently index.js. My main file is completely empty. By the way, can I just quickly, do people see this? Is this big enough? Yeah, cool, sweet, great. Otherwise, this would be terrible because you would just be watching some blurry text for no reason for a solid 10 minutes. So anyway, if I just do something simple like console log hi, and then I run the whole thing, nothing really happens, right? I just get hi. The same way it would also work in Node.js. No big difference here. Nothing super exciting. I can exit this. As you can see, nothing opened, no window happened. And what you might know from Node is that I can do things like this, right? I can just say fs, require fs, and that's how Node works. One thing that's cool here is that in Electron, I have additional modules. I'm just going to get 2 of them. I have the application and the browser window, and I require that from Electron. And what I can do here, I can say app on ready. And this is really just the same thing as maybe if you used jQuery before, right? The on DOM ready. This just means the process is ready. You can now do things. The process is alive. And what I can do is I can say new browser window. And if we run this again, we now have a browser window. That's a typical Chrome window. It is completely empty. There's no page in here. Chrome was never meant to be empty. So we can open up the DevTools, but they don't really do anything because they're like, there's nothing here. This shouldn't happen. Chrome actually never expected for you to be able to open a window without a page in it. So let's close this again and start doing things. So one thing we can do is we can say, let main window. This is now my browser window. And then I can say load URL. And I can load a file locally, because in Electron, we have access to the whole file system. We just have normal Node.js access. I can get this file from wherever I want to. I could load it from the internet, but from local file is slightly more interesting. So I'm just going to make an index.html. I'll put some stuff in here. Nothing super exciting. I'm just going to do something boring. Just going to say hi, right? And if I run this again, as you would expect, we now have a window with stuff in it. So far, not crazy exciting. Again, I know this is probably not going to rock anyone. But if I open up DevTools, and let me load this, I can actually go ahead and do all the Node things in here. This is now the file system object with the read file, write file. I can do everything I can do in Node in here. Anything you can find on NPM, you can use from this window without limits, even if it's native. If you want to use SQLite here, go for it. In fact, there's a little thing. I don't know if any of you know Razer keyboards. As an example, they're like these keyboards that, for whatever reason, have gigantic amounts of lights. I made a little module called Razer Chroma that lets you control those lights from your Node app. Now, in Slack, if you get a message, you get a beautiful rainbow across your keyboard. You can turn it off. It might be annoying. But you can do whatever you want to do. It just works. So let's close this again. Thinking about this window, I'm going to do 2 things. First, I'm just going to add a container here. That's where I'm going to start loading my editor as soon as I have it ready. Then I'm going to go ahead and make a style sheet. I already have this thing referenced here. So I'm just going to say a style.css. And this is going to be real boring, right? Nothing super exciting. I'm just going to say, hey, make this container as big as the page, and make the editor also as big as everything else. One thing you might notice here is that I'm just very liberally using VH, which is the viewport height. It just means make it as big as the window. It's a new feature, somewhat newish, definitely not available in older versions of Internet Explorer, but we don't have to worry about that because it's just Chrome, and it's Chrome on every single platform, and whoever runs Slack runs my version of Chrome, the one that I wanted to use, which is fantastic. I don't really have to worry about any other mess of dealing with older browsers. I can actually write JavaScript the way it is today, which is very convenient. Now and then, again, Node is just available here. So one thing I can do is I can just go ahead and do this. Again, this is Node.js, but we can just do it. It's fine, right? We can just run this. So I can make a renderer.js. And in here, again, I'm just going to show you that this works. I'm going to say hi. We run this again. I'm going to open up the DevTools. And in here, I now logged hi, right? Because that just worked. The same way Node.js works, the same thing works here. Now, let's actually make an editor. That's the interesting part, right? That's the part that we care about. So I'm going to go ahead and say, while we're doing this, I'm going to go ahead and say npm install save Monaco loader, which is just the Monaco editor, right? That's just the thing that you just saw on the website, packaged up on npm. So I'm going to go ahead and say loader, const loader equals Monaco loader. Actually, I'm just going to write this a little bit quicker. Then Monaco. Right? Now we got the Monaco object. And there we go. So what's happening here, real easy, real quick. We're just using this Monaco thing that I could also use on a website, except that I'm now using it in Electron. And all I'm doing is I'm saying, make a new editor and put it into the container object that we just created right here. Right? We have this container div, and we're just putting the editor in there. Otherwise, we're just configuring it a little bit. We're saying, hey, the language is JavaScript. As a theme, please use Visual Studio Code Dark, which is what you're seeing here. And please worry about the layout. I don't really want to do anything else. So all in all, 10 lines of code. Nothing super exciting. But let's try this again. Let's just run the whole thing. And if I didn't mess things up, we should already be pretty far. There we go. This already doesn't look too bad, right? I can already start doing things. I can say loader, .then. It doesn't really know anything, right? This is currently pretty dumb, but it definitely works. It's a normal editor. I can do things with it. I can already package this up, go home, sell it, $5 a piece, become rich. Took me a total of, 10 minutes? Obviously, this code editor has a major flaw, which is that it can neither open or save files, meaning that currently the best way to save anything out of this window is to take a screenshot, which is not ideal. It's not the best way you want to do things. So let's just say I want to do anything, right? Let's just say I make a new file, and this is called infoshare.txt or JS, right? I want to say console log, hi, infoshare. And I save this, and then I open up this folder. OK, so this is my folder. And I run the editor again. Normally, what I could do is I could just take the file and move it onto the window, and it would open it up. It does the same thing here, but currently, Chrome is intercepting the whole drag and drop operation and saying, aha, you wanted to navigate to this file. I got you. I'm going to open this file, right? Which is not what we wanted to do. We didn't want to navigate away from our editor. We wanted to stay on the website that we have initially opened, the index.html. Normally, on a website, you couldn't do anything about that. Maybe you've seen websites before that try to keep you from navigating away. They pop up all these alerts. It's pretty annoying. But they are pretty annoying because they literally can't do anything about it. We sort of control our own world. We can control navigation. We can sort of say, no navigation, please. I want to stick where we are. So I'm just going to do that because we can. It's kind of cool. So I'm just going to go back to my main window here. What I can do is I can say main window web contents, which is this object that lives in every single Chrome window, except that it's usually not accessible to you. It contains all the events that Chrome has to handle internally, one of them being will navigate. It's pretty classic. What I'm going to do is I'm going to say, whenever you want to navigate, we receive the event and the URL. I'm just going to say e.preventDefault. And that's literally all that's necessary to ensure that you can never navigate again. We're just going to stay on this page forever, ever after. We can also be lazy and just see where we're going, right? So let's run this again. This is now my editor. I can, again, take this file, drag it on here. As you can see, we didn't navigate away. We're still on this editor, and we logged the address right here. Sweet. So what I'm going to do now is I'm going to take this file, read it in, and then open it in the editor. For that, I need to be able to talk to the actual window. Right now, if you remember this graph that I had at the beginning, I had the main process, which is this thing, this invisible thing that can open up as many windows as I want to. And then I have this other file, renderer, which lives in a different process, two different processes. And I need to somehow get this URL from process 1 to process 2. That's pretty cool because Chrome has something called the IPC, the inter-process communication. Again, that's not available to you in a normal website. If you just are a Chrome consumer, you can't really do anything with that. It's not available to you. In Electron, that IPC is available to you, and websites get to talk to each other. Windows get to talk to each other. So what I'm going to do is I'm going to say main window, web contents, send. And this works sort of like any send you've ever seen. I can just say open file, and then I'm going to send the URL. That's all that really needs to happen. So we're done with that. And then in here, I'm going to say now that the editor is created, I'm going to require one more thing. I'm going to say const IPC renderer require Electron. So that's the counterpart. IPC renderer is a module that I can require from Electron. It allows me to get information from the IPC. I can send messages back and forth, can send messages around, can do things with that. And again, it's pretty simple. It's just JavaScript. So I can just say IPC renderer on, open file, do a thing. In this case, it's the file and the URL, right? Those are the two things we receive, I think. We'll figure it out. And now I'm, again, just going to log it here, just to make sure that I actually did things right. Cool. Cool beans. Let's try this again. OK, I'm going to open up the console right here. I'm going to drag this on there. And that actually worked, right? There we go. This is the address we wanted to have. Now, this is going to be shockingly easy, and I'm kind of ashamed how easy it is. But basically, all I'm going to do is I'm going to say I'm going to read the file using the file object from Node, because reading files in Node is that easy, right? That is a solved problem. We've been doing that for years. It's pretty easy. And then I'm going to go ahead and take the data of the file that I read and just add it to my editor. The editor object is not really important here. It's basically just standing for whatever website you have built or whatever web application you're working on. The fact that I'm using this editor is just like a replacement. Imagine whatever you're doing on your web application, right? It could be the same thing. One thing that's, of course, missing is I don't have the fs object yet, so let me do that real quick. Const fs equals require fs. There we go. And now, let's try this again. And ideally, what I want to see now is that I drag the file onto my editor, and instead of just navigating away anything, it should just open it up in this editor. And that actually works. Sweet. Right? I now have a thing, and I can say const x, and my editor already understands that x is nothing because console log doesn't return anything. But again, we're now at 4:30. That took like 15 minutes. I can now package this up. It runs on all platforms. It runs on Windows, Mac OS, Linux. It is safe. It doesn't really access anything on the internet. Therefore, it's as safe as any other local application. It's fast. It's pretty convenient. I can just package it up. There's nothing really else to be done here. And sort of like all other applications, I might want to do more things to it, right? I might want to be a little bit more creative and do things that I also can't do in a website. One of those things is making transparent windows, or windows that don't have a title bar. Again, that's something you can do in Electron. I know I keep repeating myself, but this is something that Chrome is perfectly capable of. It just doesn't expose it to you because it's not available as either a web standard or because it would simply not be safe to do those things from a website. So let's just go and do it. One of the things we can do right here, we can just say title bar style. And I can say hidden inset. And if I did that right, the title bar should disappear. And now my editor looks way cooler, right? I don't know if you can really see it, but it doesn't have the title bar anymore. That just works. You can just go ahead and do that. In the same way, you can also make your window completely transparent, which definitely works. Has the benefit that if you ever wanted to make a round window, go for it. Want any weird shape, speech balloon, you can do all those things. All right, so that was pretty much it. Anything else you can do in Electron, if you think about Slack, which of course as a code base is dramatically bigger than what you just saw, it doesn't really get more complex. It's sort of this, just like more of it, right? But the code itself is pretty easy to reason about. It never gets way more complicated. Everything we do is pretty much what you know from Node.js development, normal JavaScript development, except that we can very closely track whatever is the latest and greatest, right? We use async await because Chrome already supports native async await. We don't have to transpile that down to something weird. We can use all the latest CSS features because we know we have those available, and that's pretty powerful. Now, I have a few more things to say, and then I'm going to be done here. One of them is that the Electron user base is pretty big at this point. We at Slack aggressively open source things that we work on. Microsoft does too. GitHub does too. By the way, those are I want to say, the big three, Microsoft, GitHub, and Slack, the ones that build major Electron applications. There are so many packages out there for things that are sort of like between worlds, that are both in JavaScript as well as native. We, for instance, made this package called Windows Native Notifications, which allows you to send native notifications. There's all kinds of things around title bar apps, right, if you want to move them into your menu bar. This is a fantastic resource. NPM as a package manager is pretty solid. And now that we're building desktop applications in JavaScript, we can just make use of the vast packages available on NPM. It's kind of amazing. The other thing is that you don't really have to do things the way I just showed them to you. There's now a cool new CLI, which allows you to automate the whole thing. If any of you have ever used Ruby or Ruby CLI, this might be a thing that you're familiar with. It's sort of like a UMan generator. The idea is that you say Electron forge new. It's going to make up a new application for you. Has a bunch of templates. But even easier, you can just say Electron forge make, and it's going to go ahead and make all the binaries for you. So it's just going to spit it out automatically. It works with all the CLI tools available that are otherwise available, making it dead easy for you from one machine to build a little application. It's pretty amazing. It's kind of cool. And then lastly, let's summarize what we just learned and what we talked about. The first thing is that we really, really like JavaScript, and we really like JavaScript on the desktop, mostly because it is extremely powerful. Again, the idea that 4 people can build an application people actually like on all platforms is pretty remarkable. There's this thing on the Windows Store where you can submit traditional Win32 applications, which is something we have done. And last week was the big Microsoft conference. And as it turns out, Slack is one of the highest rated applications, which makes us very proud, but it makes us especially proud because we're only 4 people, right? This is something that normally would take a gigantic team because you have at least 4 people for each platform. You got to re-implement things all the time. This is really powerful. This sort of changes things. And even GitHub, an application that was previously available in 2 separate teams. They used to be GitHub Desktop on Mac OS, and then they used to be GitHub Desktop on Windows. 2 completely separate teams, 0 code share. They have now moved to Electron and have just 1 team that also coincidentally has only 4 people and is quite impressive. If you haven't seen the new GitHub Desktop app, it's pretty amazing. And then lastly, if you want to see anything and try this out for yourself, I recommend Electron Forge, which is very powerful. It's a really easy way. If you at any point have 20 minutes and you feel like you want to try anything, build a little desktop app, this is the thing you would go and try, Electron Forge, real quick. And then, at the very end, if any of you have any questions, which is hopefully the case, usually when I go and talk about Electron, there's always like 5 or 10 people that actually go and try to build an application. If you have any questions about it, just hit me up. I'm on Twitter. My DMs are open. You can always talk to me. You can also just find my stuff on GitHub. It's quite excellent. All right. We're 10 minutes early. If anybody has any questions, this would be the time.
Guys, if anyone has a question, please raise your hand. Pass the microphone. Oh, please wait. You'll get a microphone in a second.
What is the memory footprint of this small application?
OK. Actually, there we go. This is better. Thank you so much. All right, sweet. Let's just look at it. So we currently have Electron running. This is very small. You can't really see it. But right now, let's just include memory here. Our little editor is using a total of about 200 megs, including everything, which isn't really fair because, no, actually, never mind. This is also actually Visual Studio Code. We're currently using 50 megs, which is pretty all right. It's not fantastic, but it's pretty all right. We always got to consider the fact that if you have a machine that can't afford 50 megs of memory, chances are you won't be able to do whatever you meant to do in the first place. But thank you. Excellent question. All right. Well, if there are no other questions, thank you so much. Thanks for coming. I'm going to be around if any of you have any questions about JavaScript, Slack, Electron, anything else. I'll be around. Thank you.
Thank you, Felix.